Okay, in this video, we're going to go over section 5.2. The title is Integration by Substitution. The goal in this section is to find the indefinite integral using general indefinite integral formulas. So there's a word substitution. So this is a reverse order of a chain rule. So when we are learning all the rules of a derivative, let's say you have 5x plus 1 squared, you know that the derivative is not just 5x plus 1 and then subtract by 1. You had to multiply by this chain rule, so multiply by 5. So that's kind of like a reverse process. Substitution is we are going to find some substitution that works and we use letter U so that when you select the u nicely, let's say 5x plus 1, when you differentiate, you get this 5, and then you see the reverse order of a chain rule. So I kind of say the integration by substitution is a similar idea of a chain rule in the derivative. I want to kind of make a comparison and then some similarity with the derivative and antiderivative. So that's what it is. So these rules are all coming from very similar to the one that we just went over in section 10.1. Remember? Raising power divided by n plus 1, e to the x is e to the x, 1 over x is ln over ln absolute value x. So same thing, you see that over here. One thing to remember is sometimes when you have e to the 2x, the derivative is not just e to the 2x. Remember, there's this extra part of dx, 2. So same thing. Right over here, that's what this part, that chain part is this over here. When you take the antiderivative, you get e to the f of x. Okay? So the procedure is select a substitution that appears to simplify the integrand. We don't want to make it more complicated, so you want to select the u to make the polynomial simple. In particular, try select u, so the du is the factor of the integrand, so it cancels out. Express integrate entire in terms of u and du because we don't want two different variable. Okay, so we wanna just stick with one. Evaluate new integral possible. Express the antiderivative found in step 3 in terms of original value. So let's go ahead and then I'm gonna show you how to do this one. Now, number 1, technically speaking, what you can do is you could FOIL it 4 times, distribute this one, and then just separate integral, but it's complicated. So 5.1 strategy will not work because it's not a simple. You have to FOIL it 4 times and distribute it, and that's gonna be messy. So that's why we are doing a new strategy called substitution to make this polynomial simple to integrate. So what do they suggest to select the u? Select the u appears to simplify. Select u and du is a factor in the integrand. And then I'm going to be selecting u. Now this requires a little bit of a practice. You might not see the u. Sometimes your original u substitution that you made might not be simple. So what you do is you take a couple steps and then modify the u. Okay, but I have been practicing a lot, so I know I can select the u a little bit more faster than you do. So I'm gonna I kind of think of it as chain rule. Remember the chain rule? This part here inside of some function, right? So that's normally how I select the u. I want to select something looking like a chain rule and then inside the function to be my u. So I see some kind of a chain thing going on. Whole thing raised it to the 4. So I'm going to let this be u. 5x cubed plus 7x squared minus 5. Then my du, if I take the derivative, I need a du because I want to change now u into x terms to the u term. So I cannot have a dx, but I just have to have a du. Then derivative of the function here is 15x squared plus 7 times 2, 14x, minus 5 equals 0. So anytime you are done, you put dx. Well, take a look. My u will be 5x cubed 7x squared. So this whole thing now changes to u to the fourth. And now take a look at this one. Du is 15x squared plus 14x dx, and that's what I have over here. So doing the substitution, it looks like this. U to the fourth, and this whole thing is just du. And take a look how simple this looks. After doing a substitution, I didn't change the value. I just do the substitution. I pick something that's nice so that your integral is easy to integrate. That's the whole purpose. Okay? Then it's easy. Well, that's this one here. Raise it by 1, divide it by 1. So I raise it by 1, divide by 1. So u to the fifth power over 5. Don't forget plus c. Now, however, your original value is x. So what you have to do is after you differentiate, make sure you go back and then substitute back. So back substitute. So u is not, u really is a 5x cubed plus 7x minus 5. So this will be 5 times x cubed 7x squared minus 5, whole thing raised to the fifth power over 5 plus c. Okay? Or you can also even write it out as a 1 over 5, 5x cubed plus 7x squared minus 5 to the fifth power plus c. Now remember in 5.1, I told you that you can check every single problem. So I'm going to do the check because it's our first time doing it. So if I take the derivative of this function, then I better have this matching answer inside of the integral. So if I have y is equal to 1 over 5, 5x cubed plus 7x squared minus 5 to the fifth plus c, well, you know that this is a chain rule, so I'm going to have the 5 come out, right? So my dy dx, I have 1/5 originally, but the 5 comes down. And then you have this inside function, lower down by 1. But what happens? I have to multiply by my chain, right? The inside. What's that? Well, that's 5x cubed. That's 15x squared. That's plus 14x and then minus 0 dx. The 5 and 5 cancel out, leaving us dy dx as just this one over here. 5x cubed plus 7x squared minus 5 to the fourth power times 15x squared plus 14x. And that's what you see right there. Okay. So that's the goal of u substitution. Make the complicated looking to simple by selecting the nice u. And normally the way I select the u is underneath some function like a chain rule. Okay. So let's take a look at number 2. Okay, again, 5.1 strategy will not work because I have a fourth root and I have something multiplied, so I cannot separate the integral. So the only option that I have is use substitution. This time I see that this function is underneath, kind of reminds me of that chain rule. So I'm gonna let u as my underneath function, which is 5x to the fifth power minus 7x plus 3. Then my du function will be if I take the derivative, I get 25x to the 4th minus 7 dx. That's nice. This is a good sign when you see these matching up, because I have to have all of them disappear so that I have just nice u and du, and I see that. So that means your selection of u is very good because everything cancels out. So let's do that substitution. So if I substitute it, you get 4th root of this whole thing is what you set u, and then this whole thing is just du. By the rule, I can rewrite that as 1/4 exponent rule. Raised power divided by new power, so raised by a power 1 or 4/4. So my antiderivative is u raise it to the 5/4 divided by 5/4 plus c. I don't like that, so you can rewrite that as a 4/5 u to the 5/4 plus c. Now take u, plug it in. Don't forget, back substitute. So 4/5 times 5, x to the 5th minus 7x plus 3 plus c. Oh, here, I forgot 5/4. You can do it this way if you want. You can also write it as a 4th root of 5x to the 5th minus 7x plus 3 to the 5th power plus c. And if you want to, you can check like what I did here. And then if you differentiate this whole thing, you better get back to this term here. Right? Couple more practice. All right, so let's take a look at number 3. Now, number 3, I don't see like something square or something underneath the power, but I have a fraction and I cannot separate. Earlier, we could separate the fraction because there's one term, but look, I have a 3 term, so I cannot separate the fraction. So what we can do is, again, pick a u substitution. Totally optional which one. I'm just gonna let u as a bottom piece because it's just more terms, so it looks more complicated. And then you know that when you take derivative of constant, it disappears. So I start with the 3 term. I should have some kind of 2 terms left. So that's why I decided to let u be the bottom piece. 32t minus 7. So derivative of u, 4 times 6, 24t cubed plus 32 dt. So my du is, you can do it this way, or you can have, you see that these looks very similar after cube, but it's not matching. But you realize that there's a GCF, 8 times 3t cubed plus 4 dt. Okay. All right, so let's take a look. Let's rewrite it. All right, so I have whole thing is just u because I let the whole thing as a u. Now also my dt, and here's a little bit of a modification. Take a look at 8 here. I'm missing an 8. So here's the strategy. If you have a missing, you can give an 8 and then also put 1/8. It's kind of like when you have a 2x and then like let's say another like x plus 1. I can multiply one side by 5 and then I multiply same one by 5 and I'm not changing anything. And that's kind of what I'm doing. Because you know that this 1/8, why did I not put 8? Because you know that this can be pulled back. When you multiply 1/8 with 8, it's really 1. So I'm not changing anything. So I needed extra 8, so I give an 8 here. So I have to put a 1/8 so that it cancels out. So that's a little bit of a trick that you can apply. If you have an extra term, you can always add the extra term so that whole thing disappear. but then you have to go back and then add 1 over 8 to cancel that out. Okay, so that's an important part. 1 over 8 pull back times 8 is 1, so I haven't changed anything. All right, so let's keep going. I have this whole thing now, 8 times 3t to the 4th is just the u. And then the bottom one is u. So really I have, and then don't forget that 1 over 8 that you multiplied. So I have 1 over 8, 1 over u du, and that's a ln term. So my final answer, 1 over 8 ln u plus c. And take a look at this one, ln absolute value u is 6t to the 4th plus 32t minus 7. So your final answer will be ln 6t to the 4th plus 32t minus 7. And you can put it over 8 plus c. So don't forget to back substitute u, because your original equation was a t, so you better have a t at the end. And I will also let you check by taking the derivative, then you have to go back to the original function. So that's how you can check. Okay. All right. So number 5. So we have a couple more. I'm going to let you guys try number 4. Number 5. I will do number 6 with you so that you see different example. But number 4 and number 5 is very simple one. And then I will do number 9 together. Okay, so 6 and 9. And then rest of them you can also try on your own. So let me first give you the answer. So I will also hint you by selecting the u for you. So you can try. So a nice u that will work is a negative 1.5x. Because I do kind of see that e to the u. Okay. And then I will do this one. I will set up the problem. I will let you do the work and I'll give you the solution. So du will be negative 1.5 dx. So it's the same strategy. I added 8, so I divided by 8. So you're going to be adding negative 1.5. So there must be a dividing by negative 1.5. So if you do that properly, so this is, I'm leaving you as an exercise so you can practice. Your final answer should be, after taking antiderivative, it should be negative 2 over 3 e to the negative 1.5x plus c. Okay? So please do that number 4 on your own if you think you need additional exercise. But we did very similar thing right over here on number 3. Added 8 divided by 8. Number 5, same thing. I will set it up, and you have seen this one very similar to this one here, that 4th power, but now I have a 7th power. So what did I do? I set inside of 4th power. So similar strategy will work. You start looking at similar problem, and notice the pattern. So a nice u that will work is x plus 7. My du will be very simple. It will be dx. Okay, dx. Okay. Now here is something that I'm gonna also show you. Actually, in fact, I'll do number 5 with you because we haven't done number 5 together. This strategy. Because if you notice this one, what's happening is if I do the substitution here, x plus 7, and du is just dx, so I substitute du, but you have this missing, not a number, but a term. So that's something that we haven't done. But take a look at this. I can solve for x. Well, you have u equals x plus 7. So x right here really is also written as u minus 7 equal to x. So that's my third substitution. I can substitute that value with x. Okay, so all these is a trick, all the algebra trick. So how does it look like? If you do that, I'm going to have my x is basically u minus 7. This right over here is u to the 7. dx is du. Everybody seeing that? Now I can distribute this one. So I have u to the 8 minus 7u to the 7th power du. Now you know how to do. You can separate and then take the derivative of a u term, each one, so two different integral. And then at the end, your final answer, so at this point, it's very simple and we have done similar problems. Your answer should be, after substituting back with the x plus 7 raise it to the 9 divided by 9 minus 7, x plus 7, 8 over 8 plus c. Okay, so finish rest of them, and you can also check by doing a substitution. Okay. Number 6. What will be a u that will work? Well, I kind of see this messy thing here. Inside of inside, right? So inside of inside. So I'm going to let this whole thing as my u. Because I see the 4th power, and inside you have ln 3x to the 4th. So if I do ln 3x squared, my du will be, how do you take the derivative? It's a chain rule. This is going to be 1 over 3x squared times the derivative of this, which is 6x dx. So my du is what? 3 goes in here, 2, and then x divides with this one, 2 over x dx. So this is a nice one. I have my du already set to go. What is my du? 2 over x, so you see the 2 over x dx. Okay, so I set up the problem. Rest of them, you don't have to add anything. You can do rest of them by very simple. Substitute u, antiderivative, and then take the integral. So let's do that. I have, this will be my u to the 4th. This whole thing, 2 over x dx, just changes to du. Right, 2 over x dx. Very easy. That's adding 1 divided by new power. So 6 to the 5th over 5 plus c. And then don't forget back substitute. So you have ln 3x squared. Raise it to the 5th power divided by 5 plus c. Done. So it looks very complicated and hard, but you see that once you select the u nicely, it's not bad. It's not bad. Okay. All right, so remember 7 and 8 is your exercise problem, but I will also set up the problem by selecting the u. So, but before you see that, I want you to pick the u. Okay, see if your u and my u matches up. Okay, you can pause the video anytime and then work on it and then replay. But the u that I have on number 7, I have this u as, it's a little bit tricky. I'm going to do negative x to the negative 5. Now, why did I do that? Why did I do that? So you have this x to the 6. I knew that x to the 6 on the bottom, if I take the derivative, this will make positive 5 x to the negative 6. So you really have that 5 over x to the 6 dx. And you kind of see that part over here, over x to the 6. So I'm kind of like looking the whole picture and then try to select u nice so that when you differentiate, you have that part of them appear in our original function. So you can now rewrite the original integrand in terms of the variable u and solve. These are the things that you want to think about. What is my u going to be so that when you differentiate, you still see the part of similar thing appears with the original. So after you do this one, I'll give you the answer so you can check. Your function after you differentiate should be 1 over 5 e to the negative 1 over x to the 5th plus c. Okay, and you can also check by taking the derivative and you'll get back to the original. Okay. Number 8 is pretty easy. I see that chain rule pretty clearly. So my initial and my guess will be 2x cubed plus 7. Then my du will be 6x squared dx. And that's good. You have the x squared, x squared. So this is the trick that we did with the number 5. So when you are taking the antiderivative both sides, so I will set it up for you guys. Oops. Oh, where did it go? Oh. Well, first I should multiply by dx here, dx. So you have 12x squared, 3x, all the x term on one side, right? Antiderivative, then you have a y. Here is our substitution. U will be I think I made a mistake. It should be 2. U will be 2x cubed plus 7. So that's your u to the 5th power. Now du, look, you have a 12. You have a 6. Oh, 6 times 2 is 12. So I'm going to multiply, I'm going to do, or in other words, you can say I just need 6. So if I divide it by 2, then I have a 6. So that's good. Then I divide it by 2, then this time I multiply by 2 to cancel it out. So it looks like 2 here, 12 divided by 2. That's the modification that you made to match up x squared, 2x cubed plus 7 to the 5th power dx. And take a look at this. This now turns to 6. So you have 2 in front, 6x squared dx, that's going to be your du. This whole thing now changes to du. This part here changes to u. So I have u to the 5th power du. Then it's simple, raise it by 1. So you have 2 u to the 6th power divided by 6 plus c. Back substitute u, so you have, and cancel this out, so I get 1/3 2x cubed plus 7 to the 6th power plus c as the final answer. Okay. I said I'm gonna leave number 8, but I think I finished all the problems, so, but that's good, okay? But you can always try on your own as well. Okay, all right, here's the last problem, okay? here's the last problem. So let's try take a look at number 9. The indefinite integral can be found in more than one way. Given the integral 2x times x squared plus 3 whole thing squared dx, first use the substitution method and then find it without using the substitution. Okay. So number 9, if we do the substitution, okay, so we've been learning substitution, and you're gonna see why substitution is a little bit easier because you don't have to expand it out, but this is not too bad by expanding out. Actually, I'm thinking about this. Number 9, we are going to actually skip because you know what? Actually, let's do it. Okay, let's do it here by substitution and then here by using the traditional method. Okay, and let's see how similar and how different it is. It's kind of nice to see the use substitution and then doing a traditional method. So if I do the use substitution, here you have 2x, and you see my u is pretty easy one, x squared plus 3, because I kind of see that chain. So my du will be 2x dx. And that's nice because you have that 2x dx. And then you have u right there as a u squared. So we are all ready. So nothing to modify. So you have u squared du. Then raised power divided by new power. So u cubed over 3 plus c. Substitute it. So you have x squared plus 3 cubed over c. 3 plus c. Done. So quick, right? So this is the reason why we are doing it by substitution. Very quick and efficient. Okay. Now, let's do it without a substitution. So what do? Well, there's no way that I can do the substitution. So the one way, I'm not going to apply the derivative yet. I can do this by really doing some algebra of rewriting that as a x squared plus 3 twice. And then I will distribute all, make it as a single term. So 2x times, if I FOIL this, I have x to the 4th plus 3x with the 3x squared makes it 6x squared plus 9. And then distribute this, I get 2x to the 5 plus 12x cubed plus 18x. That's just what I have here. So I can rewrite that 2x times x squared plus 3 squared dx. I FOILed it. I have 2x fifth plus 12x cubed plus 18x dx. Now, you know by addition, you can separate the integral term by term. The first one will be raised power divided by nu. So 2x to the 6 over 6. X to the 3rd changes to the 4th. And then 18x squared divided by 2 plus c. Okay. And then what happens is this switch. So you have x to the 6 power over 3, 3x to the 4th plus 9x squared plus c. Okay. Now, is that the same? Yes, because I know we really didn't FOIL. These two are the same because take a look. If you did x squared plus 3 cubed, right? That means x squared plus 3, x squared plus 3, x squared plus 3. If you cube it, and I will, and then divide by 3, I'm gonna let you check it. If you FOIL and then cube it, your numerator should term be x6 plus 9x to the fourth plus 27x squared plus 27 over 3. Then each one you can separate it, so you have x to the 6 over 3 like here, and then 3 cancel with 9 3, so plus 3x to the fourth. 3 cancel with 27 9, so plus 9x squared, and then 3 times 27 plus c, that's just like the whole constant term, so you get the same. But which one do you prefer? I prefer substitution, and this number 9 is a really good example to show you how substitution is quick and easy. Where traditional methods, take a look at how many steps. It took me 1, 2, 3, 4 steps before I even apply integral. And then I integrated. It looked a lot longer. So I had to do some algebra work. But in here, substitution, I did not have to do the algebra work. That's why we like to do a substitution method. This wasn't bad because it was a square, but what if this was 6 power? Then I have to FOIL it 6 times, and that's going to take too much work, and then it's going to be messy. And so that's this example show you how substitution can be very helpful. Okay, this is it for chapter 5.2, and then next video we'll learn chapter 5.3.